Okay, thank you, Sarah. So my talk's going to take us on a slightly different direction because I'm going to talk a little bit about our work on the derivation of a local chloride threshold for wadable streams in northeastern Illinois. The watershed work groups that have been working in northeastern Illinois that include the DuPage River Salt Creek Work Group, the Lower DuPage River Watershed Coalition, and the Des Plaines River Watershed Work Group have been working with the Midwest Biodiversity Institute out of Ohio to develop a model that identifies and ranks priority water quality stressors in our streams and rivers. The model has also helped us identify in-stream threshold concentrations for various parameters. These in-stream thresholds could be viewed as an in-stream concentration that is protective of aquatic health, kind of similar to what you would think of as the goal of a water quality standard. Today's presentation is going to focus our work on chlorides. Before I get into the details of our study, I thought I would highlight why chloride concentrations are very much of interest to us. Over the last 30 years, chloride concentrations in surface water have been increasing across the globe, especially in our cold weather climates. The major sources of chlorides are from road salt applications as well as water softeners. Based on some of the data that we've collected, we started to think that maybe the current Illinois water quality standard for chlorides of 500 milligrams per liter was possibly not as protective enough to ensure healthy aquatic communities. So the data we used in our study was collected by these watershed work groups, as well as by the Illinois EPA. The geographical range of the data includes 13 counties in northeastern Illinois and includes 3 watersheds, the Des Plaines, the Fox, and the Kishwaukee. We used data from over 120 sites where we had paired data. Paired data include both macroinvertebrates, fish, habitat, and water chemistry. All of this data was collected during the warm weather months, which we defined as June 15th to October 15th. And the data was collected between 2007 and 2015. Now, macroinvertebrate and fish data results are presented as IBIs, or Index of Biological Integrity. IBIs are scores that represent the health of the aquatic community. The higher the IBIs, the more diverse and pollutant intolerant the community is. Illinois uses these IBIs as key indicators of water quality and aquatic health when they're doing their assessments. IBIs that are classified in the good and excellent category are considered to be meeting Illinois water quality standards. The first step in our analysis was to identify the most chloride sensitive fish as well as macroinvertebrates from our data set. And from those, we derived a weighted mean chloride value for each species and taxa. Low chloride weighted averages indicated that chloride sensitive species and taxa are typically not present at sites with high chloride, but are present at sites with low chloride concentrations. Although this is a quantitative approach, the large sample size we use makes this analysis more robust. A 20th percentile cutoff was used to identify these sensitive species. Once these sensitive species were identified, we wanted to confirm that these sensitive species indexes we created did correlate with the Illinois IBIs. We did this by calculating the number of chloride sensitive species observed at each of our 420 sampling points and plotting those results against the IBIs at each site. We did this for both fish and bugs, but on this graph here, you can see the results of the fish. As you can see, there's a very strong correlation between fish IBIs with high fish IBIs, which indicates good aquatic health, with those high sensitive chloride species. The fact that there are very few outliers, if any, is a sign that the strength of this relationship is letting us know that we were on the right track with our analysis. The chloride sensitive species that we identified and were used in this analysis are shown here in the top right. The intolerant species at the top of the graph represent the upper 10th percentile, and the sensitive species represent the 10th to 20th percentile. For the next step in calculating our threshold, the fish data was used as it was the most restrictive when you looked at both fish and macroinvertebrates compared to each other.
1 minute, Dina.
We graphed each of our sites based on IBI category, ranging from excellent in blue to very poor in red, versus the warm weather chloride concentrations that we observed in our data. We chose to set our thresholds at the 75th percentile of the sites. For the sites that were in the excellent category, we set a chloride threshold of 40 milligrams per liter. And the sites that are in the good category, that threshold was 120 milligrams per liter. Now, if you remember earlier, I talked a lot about that Illinois sets the water quality standard that should be promoting aquatic-like health at that 500 milligrams per liter. where our data is showing that a much lower standard, such as much closer to this 120, would be needed to be protective of aquatic health in our water systems. We also calculated fit scores for chloride. With chloride, we had a very low fit score, giving us confidence that the chlorides are having an impact on the health of aquatic communities in our streams. The analysis we did not just include chloride, but also include many parameters, including nutrients as well as metals. We hope that we can get all of our data synthesized and be able to present an abstract to kind of present our entire project to ECEC at next year's conference. Thank you for listening.